Okay. People of South Africa, mense van Suid-Afrika and the world at large. I've already made a video. It's a bit confusing maybe to some people about the exact nature of the contents I'm talking about. But basically, we are very suitable for wave energy, also for wave energy research and also for utilization of wave farming. We have huge potential real estate out there for wave energy because nobody lives in the sea. So millions of square kilometers is available, offshore at least, and thousands of kilometers maybe along our coastline. So we are talking about unutilized area that can probably be easily utilized if we can just come up with the right these devices and the right research towards that wave energy converter devices. Now, this is a very serious matter because wave energy, I've only said was convergent. Actually, it's divergent. There's too many different designs and devices. Many of them is like fixed gear kind of devices. They don't really adapt to any waves. They don't predict the incoming wave. Some do kind of do a control trick like Palamas maybe and so on. I don't want to say too much about other people's work. I can only say what I've myself figured out. But what we need, what you must look at, is something like wave farming, and thousands of people can actually get involved with this. But we need a technology that people in common can use, like a WEC, a range of WEC models that is optimized to do the job so that we can farm effectively and we just like buy them up or make them or whatever, but to a certain design. So a few models, not many, that has been developed in labs, and we have the blueprints, and we basically just expand the whole industry around them. Very modular, a lot of repeating, like smaller units or modules. So everything I'm talking about here, when it comes to WEC devices, it will be very modular and has certain components, and they will be. It's assumed that the industry will be constructed to manufacture these components upfront as far as possible. So you do understand it's mostly pre-manufactured with materials that is suitable for use in the sea, non-corrosive kind of materials that is long-lasting because ultimately it's actually the sea that destroys these units. So in calmer conditions, the units tend to last much longer at least, and I've said that before. So it's always kind of worthwhile to do it, but maybe in calmer conditions you can use a smaller kind of model of the same design. Now I've proposed, and this is patent level material, but I've decided to share it because I want people to contact me, or not but start a group, and I want to be involved. People can contact me if they really want to. I will provide facilities for that later on if there's a lot of my videos being viewed and liked and things like that. That indicates to me that I must go further on this. I really mean this to the whole of South Africa, but yeah, everybody that's interested and show some promise in this field can get involved. We can start a large group of people that support this whole concept of a research facility, and everybody can be involved online or whatever. But of course, it mustn't be a circus. There must be some promise shown by someone, or someone must make a real contribution. But I do believe we will ultimately need a piece of real estate that includes an area of coastline, a small area like a few kilometers square or a kilometer square, that includes some coastline that is actually only for wave energy research. and all the facilities is set up there. Like the piece of sea that's involved might have large overhead cranes to put the pilot plant WEC units in the sea easily. That you don't need boats and things, so you can have overhead cranes that runs on rails, and we don't need that much. You understand, for pilot plant, for testing a single WEC model unit, but some parallel testing can happen so that we may have a few of these crane tracks that is maybe 100-meter wide or 60 meters wide, steel cranes that is capable of picking up to say 100 tons or 200 ton. So it must be big scale steel construction there. It will make life much easier for the researchers and to actually test a model in real sea conditions. So I want this located at a place where the sea is pretty rough. But you can also do it inland, actually, if you can create an artificial piece of sea with a beach and probably dolossus to break up the wave energy. You don't want too much reflection when you do this wave energy research, obviously. So you would like to have something that shatter up the wave energy, so you don't have too much reflection. You can obviously have hybrid systems. Sorry, I'm scratching my butt. I'm just itching. My proposal is simple. It's a backward curving ramp on a hydraulic cylinder setup that you can adjust the angle of. So like it looks like kind of like a bridge, but it's only like hinged on one side on the seabed with a foundation part and maybe some channeling or focusing parts under the water that focus or channel the wave into this ramp with side rails, or not side rail, but the side channel kind of situation. It curves backwards, and there's a reason for it. On this ramp, there's a roller, but it's semi-buoyant, and it is anchored with wrapped cables to the ramp in a V fashion on each side, and maybe one in the middle, in the most basic formation. It's like 2 or 3 V cables, one on each end. Each cable wraps twice around the same roller. It makes a V shape because a cable must be angled to the roller and the ramp. It spans over this backward curve ramp, so it pulls the roller onto the ramp tight, but because it's wrapped, the roller can roll freely on the cable and the ramp flat edge. But it's just curved backwards, but it's straight from side to side. But it's curved in its up and down length backwards, so it pulls. If you tighten the cables, it pulls the roller. The cable runs at the bottom, wraps around and goes out at the bottom, and then it comes back, the V, and it wraps again and goes out. And the angle is to space the wrappings of the cable on the roller, so that there's no like friction between the cable wrappings, and there's some spacing between them, a little bit of spacing. But that configuration will anchor the roller effectively if you actually tie the cable some point in the middle of the wrap, when it's in the middle of the ramp, to the actual roller, so the cable is actually fixed to the roller, so you cannot slide in any way to make it disaligned. So you have this square, or this bridge-like ramp that goes backward, like a road over a bump of a bridge, but it's angled only like a hinge, a large hinge on the bottom of the seabed, with a hydraulic system that has rubber boots, and so doesn't rust or anything. It's made of non-corrosive materials, maybe protected by a rubber boot, and it is normal hydraulics. Or even high pressure seawater. If you use very high pressure to your power station, you can actually use that pressure to operate your hydraulics. So if it's in excess of say 200 or 100 bar, and that's kind of possible. High pressure is good because you don't want a big pipes. Rather have a thinner but a thick the side thickness of the pipe is thick, but the diameter of the pipe is low. So high pressure is like high voltage, and low flow, it's easier to treat with this smearing compound that can make the water soapy or snotty, like slimy, to lubricate your Pelton wheel turbine nozzle, and also make the water just go work your mechanics much easier and smoother. So it's like a lubricant, but it's biodegradable, and that can obviously be engineered from proteins or whatever, from plant material or whatever source you use to engineer such a soapy little slimy thing. That is also protect against corrosion and stuff like that. But it's biodegradable, it becomes fish food, whatever, it just or bacterial food. It just doesn't cause any red tide or anything like that. But of course you use very little volumes or display, volumetric displacement, but more high pressure, like in a high pressure transmission line scenario for your intermediate power transmission to the power station, hydroelectric power station on the coastline, maybe Pelton wheel turbines or that kind of type, high pressure turbines, very high pressure turbines. As I say, I like hundreds of bar maybe, or at least above 50 bar. That can also say operate your hydraulics to adjust your rams to the tidal level or the wave conditions and the tide combination. But the fact is, these rollers on rams is more effective, probably much more than any oscillating water column. And the other thing I want to discuss is, of course, I said 3 V cables at least, because one of them in the middle, say, is used to operate a slider, and there's a little section or a meter wide or so section of this roller where the roller is a centimeter or what thinner in diameter. And there's a little bump there, and like it makes it like a kind of track, but that part is actually a slide part that can easily slide over this curved ram in lengthwise, and not widthwise, lengthwise, and the roller is widthwise. And as the roller goes up and down the full stroke of this ram, that it's allowed to travel with stoppers on the ends maybe, impact stoppers, that slide part moves, say, a maximum stroke of 1 meter. Now you have your one or set of 8 cylinders. Now there's 2 options here. If you use 1 cylinder, obviously in big waves, your pressure is going to vary from that cylinder, because you're not going to send it directly to your fixed pressure power station. What you're going to do is you're going to send that variant pressure, fixed displacement, fixed area cylinders output to a converter box, a hydraulic converter box that is binary controllable with these 8 bits. I'm going to explain that now. And then that controls it over, that converts it from a fixed displacement or area scenario to variant pressure to a variant displacement fixed pressure. But you can binary control it. It will be similar to a pack of 8 cylinders, say. You can have any number of binary bits, and each bit represents or controls a single cylinder, because a cylinder is either active or deactivated. It's either pumping or not pumping. So binary is the most effective code to make a few on-off devices have the most possible combinations of numeric combinations, and you can binary weight the areas of the cylinders, pistons, to make a similar effect of a variant area cylinder that is mechanically impossible, but you can do it with this trick. So let's say you have this box does the same thing, then 8 cylinders in parallel operating as a single pack of 8. and they stroke this one or stroke that the slider moves. Now what happens is you want big waves not only to make a longer stroke length, you also want the area to increase so that they pump so much more water against that high pressure to the power station. So you need a variant area cylinder, but it's impossible mechanic to build one. So you do it with this binary technique using 8 say cylinders to form a byte. Now that gives you numbers, any number of area selection between in steps of 0, 1, 2, 3 in whole numbers right to 255 of in terms of the smallest area of the smallest cylinder, the 1, 2, 4, you understand that. That is in terms of the smallest area of the ones cylinder, of the least significant digit of the binary byte. And then you have a most significant digit that will be weighted at 128. You understand? Because 256 is basically the combination with 0 and 1 to 255. Now you can obviously select any area then in terms of this minimum cylinder area. Now obviously the minimum cylinder area will limit the minimum wave you can utilize. Listen, so this is your nearshore or onshore solution. You need a controller to select the right area for each energy category of incoming wave. So you have to categorize your incoming waves. It goes into a pipeline or a prediction pipeline with a running ETA that countdowns on each wave electronically in the controller memory, or the data is sent to the controller on a broadband link from the prediction system for each unit. There's maybe hundreds of units, but each are individually have this predictive system. That may be a wave rider buoys coupled to other sensing devices, even reflected wave energy versus incoming wave energy sensors and stuff like that, but to measure the performance of your device. There's other ways. The other thing the controller must have, the inputs of the controller must obviously be the wave category, power category or energy category of the incoming wave and waves and the ETA, but the incoming one is the one closest to it now, going to hit the crests I'm talking about. The troughs is more longer and shallow, Then you have this train, and of course that can also be helpful for folding the system down when a freak wave is about to hit. But you see it on the far end of this wave train that's incoming with different ETAs and accelerations. You can calculate from the dynamic ETA that countdowns actively over time. So you can obviously calculate acceleration from that, your controller. That's an input, basically. So your wave, just-in-time wave prediction system. And then you can respond to it by folding your system under the water if there is a freak wave coming into the pipeline on the far end, and that can damage your system. So you can take evasive actions before you get damaged. The system WEC unit get damaged, it can try to brace itself, clamp itself, or do something, or lift itself out of the water, or fold under the water, whatever. And you can also use it to obviously know what wave is about to strike and when. So you can now set this right area of the cylinder pack or the one cylinder multi-pressure cylinder, a single cylinder maybe, to this converter box, and in that converter box you can do the binary selection to select the right volume displacement to a fixed period power station. So it actually basically acts the same. A single cylinder to a converter pack with binary selection, or physically 8 cylinders that you, I'm just using a byte here, it can be less or more, and you basically activate or deactivate each cylinder as a bit. Now if you deselect a cylinder, say a 0 on the binary number for that area weighted cylinder will mean that you actively decouple or decompress that cylinder. Because if you don't decompress or decouple, it will be active because a one-way valve will just pump. So obviously your water going in will have this lubricant, this biodegradable lubricant, and also anti-corrosion protecting compound, and you want smaller amounts, higher pressure, you understand. So you use less of this compound, and it's also filtered seawater, very well filtered seawater that you maybe have a smaller little pump that just feed a feeder system, that just feed this in a tank or whatever, that keeps, obviously that's a doesn't use much electricity. So you want some electricity on your WEC unit, just to drive some pumps or something, or some hydraulic. You can use you need an electrical system on each WEC to control it anyway. So to power your watertight controllers. So one input would be your incoming wave. That's the most important input. Another input would be the actual power station pressure, and your output would be your area that you select for your. And time is also just like something you can see as an input. But data in for the incoming wave trains, just in time, you and your storm or freak wave countermeasure action system. You need that data, that incoming data from your wave side that's about to hit you. You need that absolutely to make a very efficient WEC unit. And you need a power station pressure, and then you need the ability to select another input will be the actual stroke that is being done by the cylinder. So you need a linear shaft encoder, so you know how far the oscillation was in the actual after the wave has bounced back or happened. After it happened, so you pre-brace, it happens, you measure the stroke, and you calculate the energy that you do. You actually extract it. But by that means a system can be self-learning, and it does it so it has pre-programmed area levels for each category of incoming wave. So what happens now is sometimes the system try one area level of this 0 to 255 levels. 0 means there's no resistance, there's no cylinder pumping happening, but it has a 0 like a neutral of a gearbox. But say we take 1 to 255, that's more less than 1% accuracy. So it now and then it tries on a specific typical category, say 7 wave. Every time it gets that 7 category wave, it tries sometimes on that specific category in its memory bank. It tries one area smaller or one area larger. Sometimes smaller, one area larger, but sometimes on it. But now and then makes this little experimentation move. And in that way, it kind of learned that it should move to one area smaller or one area larger to get a higher efficiency energy extraction. So it hunts the peaks. You understand what I'm trying to say to you now here? So that is very useful. So you can have over months, and so you can have a controller that actually quite a short duration for the very common wave sizes, categories. You can have a controller that learns very quickly where the peaks are. And they will not be off by more than one area, or 0.5% off. Because even if they change around quite a lot, one up, one down, regularly, and it's like all very close to optimal. It doesn't matter, it stays on the peak. Because it's off a lot, it will clearly see the slope. Like with differentiation. It uses that kind of idea to climb up the mountain and stay on the peak. So it runs on maximum efficiency per any kind of category wave. Now, if you see the waves as cows, and you have a milking machine that milks the energy, the milk, out of those cows, and it does it automatically at the most efficient way, you must have a winner here. and that's the kind of thing you can do with the ramps. You can probably do it with point absorbers, anything utilizing cylinders. And you can do it similarly with maybe electromagnetic mechanical devices. Maybe harder to do, but I'm telling you something. Dynamic control and like you have with regenerative braking, but now you have kind of a regenerative shock absorbing system. Is a way to go. This is the way to go. And you must do it per wave, per bump, per movement. And you can use it for the system if you can make it act against storm conditions very quickly and respond fast. You can actually have the system running in a storm where there's maybe waves that can still be used without damaging the system. But as soon as it comes, if you have a predictive system has kind of a pipeline and every wave crest has an ETA and it's running and dynamic, and it's like a number running over time for each wave, you can know there's one just entered the pipeline. It's a very dangerous. The category is over the max, or it's marked as dangerously high, and this going to strike me now, so I can maybe utilize some wave energy in the meanwhile. But listen, I take about 20 seconds to fall down, or 30 seconds to fall down the water, so I would fall down just in time for this wave and climb myself or climb the roller just in time for this specific wave not to damage my system. So even maybe in a moderate storm or a milder storm, you can still run the system, and utilize less dangerous waves in between and just fold in, fold out, or clamp or not clamp against storm or dangerous waves, because ultimately it will be the waves that will destroy your WEC sorry people, or damage your wave energy converter. And if you can actually see them coming, there's no way they can damage you, because wind is not going to do it. Okay, so that's all I want to say. I hope you found this interesting. Okay, for deep water you can have ring boats. I'm going to talk on another video about offshore systems, but let's keep it to this now. I do have an offshore solution, but it's not so well developed than this ramp idea. Please, people, I should actually have patent rights on that, even if I reveal it, because it is my idea. That should be respected. Okay, bye-bye, people. I hope you enjoyed this video. And this is raw videos because I don't have much time to edit videos, and I like to make things on the fly. So that's just how my channel works. I just want to say something about my parser, or that CISC program I've written. That thing is not BOTMAS compatible, that older videos, that first video that I have two of. It's not BOTMAS compatible because